Hey guys, Mr. Riz here to help you understand the spring showcase for POE. I'm going to go ahead, just go over this, make sure you guys really understand kind of the details and the planning and all the little parts that you guys will turn in. So first off, if we look at the modules page here, we got the overview, which is what I'm going to go over here to help kind of explain some things in my own words so you guys understand what I'm looking for as the evaluator. And then we got 6 parts that you guys will turn in. And in this video, I will go over in detail all 6 parts. The first part, though, is the overview. So if you get the gist, after that, you can pretty much stop. And then later on, as you work on each individual part, look at those individually or go back and watch this video at those parts. So let's get this started here. Spring Showcase. So the goal and the objective of this is to have students teams that will apply their engineering principles to design, build, program a functional carnival style game using Vex components and Python programming. All right, the goal is to create an engaging and interactive game that showcases mechanical design, problem solving, and coding skills. So basically, put together everything that we've been doing throughout the year and make a game out of it. So with this game, you are going to be making as much of it out of Vex parts as you can. Now, some games will require their own separate pieces, but the game is going to be functioning using Python code on a Vex brain. So we're going to have inputs and buttons and sensors that all go through. So some examples of those games you could make would be like Skee Ball, Papa Shot, which is like that basketball competition game where you have 2 basketball hoops and you have a timer that's counting down. Pinball, a claw machine, some type of coin pusher. Basically, if you have some idea that something could be at a carnival, let me know. So the teams, once again, you guys will be using Vex robotics parts to make those, and as well as potentially some other construction physical game structures. The biggest thing is that we're going to be coding this, so this is not just making something that runs non-electronically. We have to have some type of coding here, and this is all going to be Python code that you guys will be using to integrate those. So the key requirements here is that there's a mechanical design. So the games must be structurally sound and demonstrate effective mechanical engineering concepts. So you are using our simple machines that we've talked about before. You might be introducing gear ratios. You're going through and making sure nothing is falling out. So we're looking at leverage and all those things. Everything's working. The next requirement is that there needs to be some type of automation and programming. So the teams must incorporate Python programming to control the game elements such as, scoring, timing, movement, or any other automated functions. Okay, so that means that the computer is doing something. There is some electronical aspect to this. This is not just something that is out there and people walk up to it. There's a game, there's a timer, there's buttons that they have to press, something to that extent. Okay. Next part, creativity and themes. So teams should add creative elements to enhance the visual appeal of the player. So when you start making a game, add some stuff to it, add some pizzazz. It might be one of those things where you have, the idea of what you want to make, and then you're like, okay, well, maybe can I add some Minecraft movie themes to it to make it a Minecraft movie themed pinball machine or coin pusher or a claw machine that has a bunch of different science elements built inside of it, but make it interactive. The goal here, once again, is this is going to be at the spring showcase, and we want to get people over and interested in what we are learning in the classroom. Next, the game must be fully operational and engaging for users. So that's going to be a thing as we go to our STEM showcase. I don't want you having any of your games really fall apart. It's got to be ready to go with normal user use. So if some little kid comes over there and really just starts smashing all the buttons and breaks it, that's their fault. But if somebody just presses a button that should be pressed and the thing just starts falling apart, that's on you. And then next part is our documentation and presentation. So teams will document their design processes, challenges, and solutions, and a final presentation will be given to showcase their work at the Spring Showcase event. So kind of the big project phases here is our researching and planning. So this is what you guys will be doing first. You're going to basically figure out, select a game, understand the history and mechanics of the game, and develop a plan of how to implement that in your project. Next, we're going to be designing and prototyping. So you're going to sketch out a couple ideas, identify what VEX components you would need for that project, and then ultimately create an initial prototype. With their construction and programming, you're going to be building their game using your VEX parts and also integrating the Python programming for interactive features. So this is going to be the building part. Next, testing and refinement. Going through that, engineering process where we are going through figuring out an issue, how does the game function, refining those mechanics and codes wherever needed, and basically being ready to prepare for a final presentation. And lastly, the showcase and presentation. So the teams will present their project and let other people play at the Spring Showcase. So once again, this is a really hands-on project that will provide students really a fun and challenging way to apply your engineering and programming concepts that we've worked on throughout this whole year. So now, if you kind of have that idea, let's look at each individual part, what I'm looking for as the evaluator. So part one, what you're going to do is to select your carnival game. And what I want you guys to do is to research that carnival game, whether it's Pop a Shot, Coin Pusher. Some people are talking about making Connect 4, or even somebody was talking about like a robotic petting zoo. All right, try to go through and figure out, okay, what are the key mechanical principles behind that? Okay, what are the rules to that, the gameplay flow, and the design features? So additionally, I want you guys to look up some historic background on those, because once we know kind of the origins of those, especially if you look at like, oh, a pinball machine might be like super complicated. You think if you go to any restaurant that has a pinball machine or any arcade, the ones that are out there are crazy advanced now. But if you look at some really old pinball machines, you can understand the mechanical process behind it. And in fact, some of those really old pinball machines, you probably can make something that's even a little bit better than those. Okay. You want to look to see kind of how it evolves over time because that's going to help you kind of guide, be like, you know what, I can't make a current, 2025 pinball machine, but I can make a pinball machine that was like in the late 1960s or something like that. All right. So with this, you guys are going to create a Google slide, research and planning. Make sure you guys submit this either as a PDF or if you give me the link, I have access to it. I want a slide that shows the mechanical principles of the game. So this identifies the key types of motions. We've talked about rotational motion, linear motion, oscillating motion. So, what are those types of motions that are involved throughout the game? Okay. I'm looking for those vocab words. Next, the rules. So go in detail. Tell me, okay, what are the rules to the game? Okay, do you play until you drop your ball, or do you get three balls in the game? Do you keep going until the timer goes out? Is the highest score wins? Are there point values? What is the objective of this? With this, you probably should also have a gameplay flow. So this is going to say how the user is going to interact with this. So how does the user start the game? How do they play the game? How do they know when the game is over? Okay, how do they determine whether they won or they lost? Or is there even an option to win or lose? And then next, what are the design features? Okay, so what are the key features of this game that really need to be involved in your project? Okay, so if you're going to say you're going to make a coin pusher, okay, think about the key things with the coin pusher. With the coin pusher, you have a slot where you drop down your coin. There's a automated moving mechanism that pushes the coins. And then there's usually a slot or tray that collects the coins and also counts them as they go in. So you can get tickets. There's other things that go on. If you look at some other coin pusher apps that go through, they have targets that you're trying to hit as well with the coins. So try to go through and find out those things that really make the game that identifiable as the game. And then also show me some historical background. So tell me the origin, when did this start coming out? How has this evolved over time? You might want to put a couple pictures of some older ones and some newer ones, and then some really, and its significance to like some kind of carnival or arcade entertainment. Why is this important? Why are we doing this? So you'll make that Google slide. Once again, this is just kind of the research part. So this isn't going to be like super big. Really, if you have a slide for each one of those, 5 slides, a couple sentences each, and a couple pictures. No biggie. That should be it. Next, part two, the design and prototyping. So this is where you're going to generate 3 distinct concept sketches that each represent a different approach to recreating that carnival game with Vex components. Each one of these sketches should illustrate the mechanical layout, the player interaction, and the moving parts. So once you get that done, you will also create a decision matrix comparing the concepts based on at least like 4 ideas. I given examples of feasibility, complexity, functionality, creativity, potential successful implementation. After you get that decision matrix all completed out, evaluating those, you're going to write a decision matrix statement saying like, hey, this is the one we are going to choose. So with this, you can make a Google Doc or Google Slide. It doesn't matter. You're going to submit a sketch, actually 3 sketches. So each one I'm going to be looking to make sure that the image is clear and neat so I can look at it and I can see exactly what's going on. The image has some rough dimensions. And when I say rough dimensions, length, width, height, I don't care, exactly where the hole is located on a certain object, but, how big is this going to be? How wide is it going to be? How tall is it going to be? And then probably the most important thing is that you label the VEX parts. Okay. Now with those, I'm talking about like the VEX motors, the sensors. You don't need to lay out, be like, oh, I'm going to use this 2x2 channel right here, or I'm going to go ahead and use this, 5 inch long screws. No, I'm just going to say, okay, these are the motors. These are the things that you're going to have to worry about in your programming. Okay. So you're going to make 3 sketches. So if I'm going to go through and be like, okay, how many different ways could I make a coin pusher game? Or how many different ways could I make a pinball machine? So sketch them out. They might look different. One might have more sensors, one might have more motors, one might be a combination of the two, one might be super extravagant. That would be really awesome, but it has like the vision sensor, a distance sensor. It also has 3 different motors that control this feature and also has lights that are turning on and turning off, all those different things. So you can make really 2 sketches that are very similar, just one has way more components than the other. You can see how that would evaluate in your decision matrix. So get all 3 sketches there. And then what you guys will do is you'll make the decision matrix kind of rank 4 different categories. I will let you pick whatever category you want. So if you're kind of stuck on one idea, if you can pick 4 categories that really make that seem overwhelming, go ahead and do that. And then you'll make a decision matrix statement. Say, okay, I'm choosing this because it was the highest score in these, and that's what we're going with. Okay, we've done decision matrices before. You guys should be familiar with this. Okay, now part 3. Let's talk about the construction, the CAD model. So, like we've done with the other projects, as you start building this, what I'm going to have you guys do is to make a CAD model of this. The CAD model should be fairly accurate to your design. Now, certain things are going to be maybe a little bit off. Some of the pieces we have in our CAD files are not exactly the same length. So we just try our best here. If you do have any features that are going to be non-Vex parts, please let me know because I will make those. Most of you guys have not gone through IED and had the full Autodesk Fusion. You might be more familiar with Inventor than you are Fusion. So I will make those, but I need at least 2 days in advance. So if you're going to be using a Connect 4 board, I can make a Connect 4 board. You just tell me what it's going to look like, and I'll make one for you. You will then just add your Vex component parts to that model that I will make for you. But I do need some time with that. When you guys do make these, we'll make sure that it is completely fully assembled, and then you have a variety of joints. So not everything should be nice rigid joints. You should have maybe some revolved joints or slider joints showing the actions that things are going to be doing. Okay. Next part is the programming. Here is very simple. You're going to send me, once you get it all finished, ready to go, you're going to send me either a picture or the code or basically, Word document that has the Python code that goes through here. The Python code should have some pseudocode in it that describe what each section of code does. So if you have a section of code that, starts the game, or you have a section of code that, makes the player score increase, or goes to 3 pointers after when there's 10 seconds left to go in the game, You have that written out there. So that all goes through. Pretty straightforward on that one. And keep in mind, like you can have one member of your group work on the Python code while the other member's working on the CAD file. That's completely fine. All right. Next, part five. Nothing to turn in here. This is just going to be, does your project work the way that you described it was going to work in your decision matrix? So I'm going to go through here, kind of self-evaluate. Hey, is it working? Is there any big issues, any small issues? Pretty much if you can get it work the way that you said it was going to work, there's 20 points. So nothing to submit for part five. And then part six here. Here is the big one. This is the STEM showcase here. What you guys are going to do is you're going to create some type of poster board. I would prefer a trifold project board. And on this, you guys will have a brief history of the selected carnival game. Feel free to use that slide that you have from before and just, hey, take that as a picture, put it on the board. An explanation of the mechanical principles used. Once again, the rules of the game and all that you can take from your presentation. We're going to put it on a poster board, okay? We're going to have our three concept sketches, so don't lose those concept sketches. So you can say, hey, we had these three different things to choose from. Here's our decision matrix that we use to evaluate those three. Here's our decision matrix statement. Guys, don't do this process all over again. Please take the stuff that you had before and add it to the board. So don't lose this stuff. Think about it. You're going to have a printout of the CAD file. So we'll go through the CAD design. We'll take a nice isometric picture of it so people can see, hey, we had the CAD model, and we'll also print off the Python code. So basically making a display that somebody could walk by. Not only can they see and interact with your game that you created, but they can also look and see the connection of what we're doing inside the classroom. They can see, okay, here's the history. This is our research to this game. This is actually our idea of understanding the problem statement here. Here's us developing solutions, creating ideas, working with the decision matrix. And then here is us doing 3D modeling. Here's us doing some coding. Here's it all together, wrap it up. Here's our project. It is not just us building with some tools, it's us working in an engineering process. So you guys can see here, you have everything listed that we are just talking about: history, mechanicals, concept sketches, decision matrix, CAD model, Python code. And then lastly here, the teams will present their projects at the Spring Showcase, where attendees can interact and play with the games. If a team cannot attend the event, you must create a comprehensive video presentation that includes all the elements. So basically, it would be make a video of you going through talking about each one of those individually, because at the Spring Showcase, people are going to come up to you and just ask questions. They're going to be like, hey, what's going on? How'd this work? You'll answer those things. Make a video that goes through and explains that process. So that is the project. And I'm realizing here, you probably have been watching this video and wondering, the most important question to you is how many people can work together on this? I would prefer groups of two on this. Now, if you want to work in a group of three, it's got to be good. And I need you guys to ask me before you start working on it. Clarify with me if you are working in a group of three. And if so, you're going to have to tell me not just the research part, but give me an idea of your design concepts. Okay. If you're going to work in a group of three and all you're going to do is make a single version of Papa Shot, not quite. But if you're going to work in a group of three, that you're going to make a Papa Shot game that's going to go through using like real basketballs and a basketball hoop. That's going to keep scores. It's going to have countdowns. It's going to have lights that flash. When we get to 10 seconds, now we got 3-pointers, and it's going to save an all-time high score. Now we're talking that's a good project, okay? But a simple Papa Shot where people are shooting basketballs and just counting down how many they get within 30 seconds, that's not like that difficult for one person to do. Probably pretty easy for two people to do. If you were doing three, I want bells and whistles. Okay, thank you guys for watching this video. Once again, if you have questions, email me, ask me, let me know. We're going to work together. This is my first year making this, and I'm really excited to see what we can do. We can make this Spring Showcase really fun and interactive and get more people involved in the engineering classes. Thank you guys. Have a good one, and I will see you later.